Welcome to The Explainer. Today, we are going to break down the one big idea that's behind, well, almost every single piece of software you use. We're talking about the apps on your phone, the websites you visit, all of it. And we're going to do it by looking at something you probably don't think twice about.
It all starts right here, with this really simple, super familiar action, just using a remote to control your TV. But what you might not realize is that this basic little interaction, it holds the key to a truly revolutionary way of thinking in the world of modern software.
So what's the connection? Well, it's huge. Turns out that simple click is a perfect, real-world model for this incredibly powerful design philosophy, a philosophy that lets developers build the mind-bogglingly complex systems we use every day. And trust me, by the end of this, you are going to see the world of software completely differently.
All right, so how do we start thinking like a software designer? Well, the first step is to kind of shift our perspective. We need to stop seeing the world as one giant, single process, and instead start seeing it as a collection of individual things that interact with each other. We call them objects. You see, instead of trying to write one massive, super complicated program that does absolutely everything, developers break a big problem down into smaller, much more manageable pieces. And these pieces, these objects, they can represent real-world things, like a person, a car, or even an online order you just placed.
But how do programmers actually define these objects? I mean, they don't just pull them out of thin air. First, they've got to have a blueprint.
In the world of programming, this blueprint is called a class. Now, a class is the master plan, right? It isn't the thing itself, but it describes what all things of that type will have and what they can do. It's the recipe, not the cake.
Okay, let's make this real. Imagine a class called washing machine. This blueprint basically says, hey, any washing machine we create is going to have attributes like a brand name and a model name. And it's also going to be able to do stuff, right? Like add clothes or add detergent. Those are its services or its actions.
So if the class is the blueprint, then an object is the actual washing machine sitting in your laundry room. It's that specific, real-world thing that was built from the plan laid out by the class.
And here's a more, let's say, official example. The patient class is the blueprint. It defines that all patients are going to have things like a name and an address. But an actual patient in the system, say John Smith, he is an object created from that class with his own specific details.
Okay, but these objects don't just sit there in isolation. That wouldn't be very useful. They need to interact with each other to actually get anything done. So the big question is, how do they talk to each other?
Let's circle back to our trusty remote control. When you press that power button, what's really happening is the remote object is sending a message to the TV object. It's a request, asking it to perform a specific action. The TV object gets that message and then runs its own internal method, or its behavior, for turning on.
This diagram here, it shows us the more formal way of looking at that exact same idea. You've got a customer object sending a message to an order object, basically asking, hey, what's your status? It's the same exact principle as the remote and the TV, just one object making a request of another.
Now, this whole idea of messages leads us to one of the secret weapons of modern software design. It's this powerful idea that you don't actually need to know how something works on the inside to be able to use it.
Just think about driving a car for a second. You only need to know how to use the steering wheel and the pedals, right? You don't need to be a mechanic and understand the complex inner workings of the engine just to drive to the grocery store. All that complexity is hidden away from you.
This concept has a name. It's called encapsulation, and it's just a fancy word for packaging an object's data and its methods together and hiding all the messy, complex reality inside what programmers call a black box. You know what goes in and what comes out, but you don't need to worry about what's happening inside.
So why is this so important? Well, here's the magic trick. If the guts of your TV suddenly fry, you can get the TV fixed or even buy a whole new one, and you don't have to replace your remote. Why? Because they're separate, encapsulated objects. A problem in one doesn't cause this catastrophic chain reaction that breaks everything else. That is the real power of the black box.
All right, so we have these neat, self-contained objects that can talk to each other. But imagine you're a developer. How do you create new, more advanced objects without having to completely reinvent the wheel every single time? Well, here's secret weapon number 2, inheritance. The best way to think about it is like this. Say you want to create a blueprint for a smart TV.
You don't start from zero. You start with the blueprint for a regular TV. The smart TV inherits all the basic TV features for free, like turning on and changing channels. And then you just add the new, cool stuff, like connecting to the internet.
And this shows the idea perfectly. Both a student and a teacher are, at their core, just specialized types of a person. So they automatically inherit all the common traits, like having a name, but then they add their own unique features. You know, a student has a GPA, a teacher has a subject they teach.
And check this out. This is how programmers draw this relationship out. See those arrows? They point from student and teacher up to person. That little arrow is the key. It means they both get all the properties of a person automatically. It makes the whole design so much cleaner, more efficient, and just logical. So we've talked about objects and messages and these powerful black boxes and inheritance, but why does this way of thinking really matter? What's the big picture here that makes this the foundation of pretty much all modern software?
Well, it all boils down to this. These ideas are what allow developers to manage almost unimaginable complexity. By organizing software into these logical, reusable, self-contained objects, they can build and maintain the massive applications we depend on every single day, from banking apps to social networks, without the whole system just collapsing into total chaos.
And here's what's so cool about this. It's not just about writing code. It's a powerful way to think about and deconstruct any complex system, whether it's how a company is organized or even how a city works. So now that you can see the world in terms of objects and messages and black boxes, what complex system around you suddenly makes a whole lot more sense?